Thank you for attending this webinar sponsored by NEC Corporation. To learn more about the Programmable Flow networking suite featured in these use cases, please contact your NEC account rep today or go to NEC Corporation of America's website at www.necam.com/SDN.
To find additional SDN, OpenFlow, and network function virtualization resources, visit ipspace.net/SDN. Everyone is talking about service insertion, so let's define it. We want to insert network services, which could be load balancing, firewalling, inspection, in the forwarding path based on endpoints, which is users or applications or both. You would use this for traffic filters, or you would use this for captive portals, for example, if you're a service provider, or you might use this, and people are using this for WAN acceleration and caching. There are two types of service insertion. You can do this on layer 2 or you can do this on layer 3. Let's walk through a layer 2 case here. These are all layer 2 switches, so A, B, and S are on the same LAN or VLAN, and they can reach each other through their MAC addresses. So when A would send a packet to S, it would go from IP address A to IP address S, but also from MAC address A to MAC address S. This being a layer 2 domain, it passes straight on to S. Now let's say that we want to intercept some traffic sent from station B. When B sends the traffic to S, it still goes from MAC address B to MAC address S, but now the switch here in the middle will intercept that packet, send it down to the firewall for inspection, and the firewall would return it on a different port and it would be forwarded to S. You see that the firewall hasn't changed anything. So the firewall acts like a bump in the wire. It has to be a transparent firewall for layer 2 service insertion to work. And then, of course, the return traffic from S to A could go straight, whereas traffic from S to B would go through the firewall. And usually, you would have to ensure that you insert the same service in both directions so that, for example, a firewall can see both directions of the same TCP session. There are numerous ways to implement service insertion in today's data center networks. The traditional one is VLAN chaining. You still have a layer 2 domain, but I would have VLAN 1 here, and I would have VLAN 2 on the other side. This is how I would effectively turn this firewall into almost a bridge, which would link these two VLANs. Obviously, it's hard to implement this for host B, but not for host A in the same VLAN. It's almost impossible to implement this for individual applications, and it's a great source of forwarding loops. The moment you get something wrong and spanning tree doesn't kick in, or maybe the firewall doesn't pass BPDUs, and you get another forwarding loop around here, you will have a nice meltdown in your data center. Although this works in theory, I would be very careful to use this in practice. Layer 3 service insertion is way safer. What we do is we have two subnets here. So this is subnet A, this is subnet B. We do service insertion based on IP headers. So let's see how it goes. When A sends the traffic to S, it sends the traffic to the MAC address of the default gateway, which is here. And then this router does layer 3 lookup and sends the packet to S. Whereas if B sends the traffic to S, going to the same default gateway, this one would now redirect the traffic to the firewall. And now, depending on how you set things up, in all cases, the traffic will have to go to MAC address F. You can either do MAC address, MAC header rewrite on layer 2, or you can decide to turn this into one subnet, this into another subnet, and then MAC rewrite would be automatic because now you're doing layer 3 forwarding. And this is how people would implement, for example, layer 3 firewalls in the data center. So you would have traditionally one VRF here, and you would have another VRF here. So this would be like split view of the IP routing topology. These two routers would do routing through the firewall, and sometimes people would even run BGP between two ports on the same router to verify that the firewall is up and running. This works great for traditional VRF-based service insertion, but of course the problem is that you have to pass all the traffic through the firewall. So the router here cannot pass some of the traffic through the firewall and some of the traffic straight on, at least in the usual implementations. And of course the return traffic flows the same way. So you could either use policy-based routing or you could use VRFs. If you have the appliance next to the layer 3 switch, it works fine. If you have the appliance a bit further off, like for example the web caches, you get into all sorts of interesting problems. Question from Bob. Are you aware of any firewall vendors that have or plan to have any OpenFlow compatibility to make firewall policy programming or integration easier? Well, you see, it depends on what you consider a firewall. For example, with NEC's ProgrammableFlow, you can already program packet filters in individual switches. Actually, you program them on the endpoints or in the interim points of a virtual tenant network, which then gets translated to egress or ingress access lists on the edge ports. So if you're looking for packet filters, you can program them with OpenFlow today. OpenVSwitch has a learn extension where once you match a new flow that is matched by an access control list, you can install a corresponding microflow, so the full 5-tuple in the other direction. So with OpenVSwitch, you can use OpenFlow to program what you would call reflexive access control lists in Cisco IOS. Anything beyond that, anything stateful-ish, would usually require a lot of the traffic to be punted to the controller, and that usually doesn't scale well. So no, I haven't seen any major firewall vendor. There are obviously startups talking about that, but I haven't seen any major firewall vendor that would say we will use OpenFlow to program our firewalls. Now, how can you do service insertion in OpenFlow-based fabrics? Well, see, there's the simplistic approach. You probably know what I'm going to say now. Whenever you get a new flow, you punt the first packet of the new flow to the controller, and the controller would install the forwarding entries pointing here and send the packet back here so that it goes through the firewall and out on the other end. Whenever you get a new flow that needs service insertion, you install flow-based entries. Obviously, this doesn't work. Well, it works great in a lab. It works great if you're using soft switches where you can program tens of thousands of flow changes per second. It doesn't work that well in hardware. What does work in hardware, and this is, for example, what NEC is doing with ProgrammableFlow, whenever you create a flow list here with traffic redirection configured, the controller programs automatically a path going all the way to the egress edge port and then maps certain packets with pre-configured flow entries to this particular path so that those packets arrive at this port on the firewall, and likewise it has to do something similar on the other end. So you can do service insertion in proactive mode and with path-based forwarding so that you install the minimum number of required entries on the core switches. A number of questions around this slide. To which layer are we limited to insert a flow on an OpenFlow switch? I mean, do you think it will be possible to intercept traffic from web services inspecting the content visited? Not with the current OpenFlow standard. Currently, you can match on anything, well, on most fields in the headers, including the TCP port numbers and the number of IPv6 header fields, but you cannot match, at least with existing OpenFlow implementations, on content deeper in the packet. For deeper packet inspection, you would have to punt the packets to the controller, and then we are back to the scalability limitations we had before. So you can configure service insertion based on, let's say, IP addresses and TCP port numbers. Question: would not the appliance be required to have flow entry to reinsert the packets back to the fabric? You would usually rely on the appliance doing layer 2 or layer 3 forwarding. Some firewalls in transparent mode are very simplistic, so they don't even care about the forwarding rules. So the firewall would say, okay, if I receive packet on port A, I will send it out on port B, period. No questions asked. That's how a transparent firewall might work. If you have a layer 3 firewall, then of course you will have to configure routing table on the firewall, or if this would be, I don't know, a load balancer, the load balancer would have a routing table configured. So nothing changes on the appliance. The appliance still needs an independent forwarding table that you would have to configure independently on the appliance. And then of course that has to be combined with the flow entries on the OpenFlow switch, which yet again depend on how you configure network topology so that the packet flows end to end. How does OpenFlow reduce VLAN IDs from top-of-rack switches if every VM has a VMAC? Oh, I never said it does. If you have multiple tenants, you still need one VLAN ID per tenant segment, although at least NEC's ProgrammableFlow has ways to expand the VLAN range. Samarat, do you want to go into more details of how that's done?
Yeah, we can definitely have scenarios where you can reuse the VLANs in a different switch. But for a given switch, of course, it's limited by the 4096 numbers. And this is supported as an extended VLAN in our ProgrammableFlow suites.
So you can define the virtual tenant networks saying it's VLAN 1 on this switch and VLAN 2 on that switch and VLAN 3 on the other switch, but within a single switch you can only have 4,000 VLANs, obviously.
That's correct.
Next question, where did you place the firewall? If it's in the core, then you need many flows entries for traffic coming out of the firewall. You are absolutely correct. It depends on how the vendor is telling you how you need to set up the fabric. In particular case of ProgrammableFlow, I would place this firewall next to an edge switch. So what I would do is, yet again, this depends on the use case and your particular needs. I would probably build a leaf and spine fabric, and then I would connect a firewall to a leaf switch. This is an example how you could do things with ProgrammableFlow. Here I define a flow list, which is really an access control list. So you see here I'm matching destination port 80. And then on a particular tenant, on a particular bridge, on a particular interface, I apply this flow list in, this is sort of like a route map, where I say if something matches this flow list, then I will redirect the traffic to, this could be, for example, a web cache, and the redirect destination has to have a MAC address here, and everything else will pass. Like I said before, you can use CLI, GUI, or API to perform these changes, so you can tie this in with an orchestration system. And the follow-up question, flow insertion would ideally be based on the rates at which devices accept changes and the rate controller can handle. Is that right? That's absolutely correct. In the ideal case, you would use a proactive setup where you would configure traffic insertion using rules like this or using REST API. And this traffic insertion rules would be applied in advance to the ingress edge port. And once they are applied, then you let the client use the network. So absolutely, you have to do this at a rate that the switches support. Next question. So OpenFlow controller, that goes back to our VLAN discussion, is not overlay aware. It depends yet again on the controller and switch implementation. In the case of ProgrammableFlow, they are not using overlays to implement data center fabrics. You will see how the physical and the virtual comes together at the very end in the last use case. Next question, are there preferred methods for handling real-time flows like SIP? I think SIP is a particularly bad use case for OpenFlow, particularly if you want to match the dynamic sessions between endpoints with dynamic port numbers. I wouldn't do that with OpenFlow. Redirecting all SIP traffic based on fixed set of port numbers to an appliance, yes, no problem. Catching specific sessions and redirecting or matching specific SIP sessions, I wouldn't do that. What is the order of operation of an NEC controller when forwarding packets? For example, if you have things like we have here the flow filters in and out and so on, most of the things, if I understand correctly, are evaluated on the ingress edge router anyway. So you would first evaluate the access control lists or flow lists, and then you would do the packet forwarding, and that would bring the packet to a path that goes to the egress switch. Is that correct?
Yes, that's correct. So all the intelligence in terms of the filters are laid in the ingress switch, and the rest are essentially using the path forwarding to the egress.
So even if you have an ingress and egress access list in a virtual topology, all the filters would be done on ingress, right?
That's correct.
Are OpenFlow controllers using optimal topologies when you mix devices with different TCAMs? Yet again, it depends on the OpenFlow controller. I can tell you what ProgrammableFlow is doing in vague details, and Samrat can jump in. ProgrammableFlow would try to make the best of the situation. So if it's presented with switches from different vendors, it will try to find the maximum level of compatible features that it can use across the network. And if that means installing flow entries into every switch, it will fall back to that. If it finds out that it can do more, then it will start doing more intelligent forwarding decisions. Can we expect some kind of protocol inspection on controllers in future so we can examine deeper in then layer 4 information? I don't think this is a good use case for OpenFlow, because if you want to do deeper packet inspection, you are effectively punting most of the traffic to the controller. So why would you do that? If that's your use case, then it's way better if the controller is sitting in the switch. Next one. So does OpenFlow have potential for directing traffic based on application intelligence? Obviously, it is layer 1 to 4 aware, but what about layers 5 to 7? Right now, what you could do in theory, you can redirect traffic to somewhere, and that somewhere can then tell you what to do with particular traffic. Can OpenFlow be used to control a set of core switches but not the edge switches in a campus environment? Obviously. Yet again, it depends on the vendor, but at least in ProgrammableFlow case, you connect whatever you wish to the edge port. You have to keep in mind that you shouldn't have forwarding loops in the edge, so don't do that. But you see, from the programmable flow fabric perspective, it really doesn't matter if you connect a hypervisor host here, which has 50 VMs, or if you connect an external switch, which has 50 MAC addresses behind it. To the programmable flow fabric, it all looks the same. So yes, you can use programmable flow fabric or maybe a solution from another vendor in the core and then connect edge switches to it. Just keep in mind that by doing that, you lose the control and visibility of the edges. So all the goodies I told you about before won't apply to traffic that is switched within the edge switch.
To learn more about the award-winning NEC Programmable Flow Networking Suite or the complete SDN ecosystem NEC is building with partners, and how you can customize these use cases for your own networking needs, call your NEC account rep today or go to NEC Corporation of America's website at www.necam.com/SDN. Thank you for your time and interest in NEC.
Additional SDN, OpenFlow, and network function virtualization webinars, recordings, and workshops, as well as other resources like books and case studies, are waiting for you at ipspace.net/SDN.